Hi everyone, we now learn about the method of U substitution for integration. And for that, we're going to work through the two examples that we see here. The first of which, we need to integrate 6x times cosine of x squared plus 1. Looking at this, there are two things worth pointing out. The first is that we're trying to integrate a product of two functions. Indeed, we have 6x, which is multiplying the cosine of x squared plus 1. And this is important because there's no such thing as a product rule for integration. In fact, when integrating a product of two functions, we only really have two options. One of those options being integration by parts, which we'll learn later on in our studies, the other option being the method of substitution. And that's exactly what we'll learn here. The second thing worth pointing out is that one of these two functions is in fact a composite function. Indeed, cosine of x squared plus 1 is a composite function. And noticing that is very important, because we'll know if we can use the method of U substitution if the function that's multiplying the composite function is a scalar multiple or a constant multiple of the derivative of the function that's inside the composite function. Here's what I mean. If I call x squared plus 1 u, in other words, if I define a new variable u as being x squared plus 1, then its derivative, du dx, is equal to 2x. And comparing this 2x to the function that's multiplying the composite function, we quickly realize that 6x is equal to 3 times 2x. In other words, it's equal to 3 times du dx. And so we see quite clearly here that 6x is a scalar multiple or a constant multiple of the derivative of u. And in fact, we could write it here as well. We could go 3 times du dx right there. And that's what tells us that we can use U substitution. And here's how to do that. The first thing to do is to rewrite our integral in terms of this new variable u. And here's what I mean. I can state that this equals to the integral of 6x, which I replace by 3 times du dx, so that's 3 times du dx, times cosine of x squared plus 1, which becomes cosine of u. And we have our dx at the end here. And just to be clear, u was the function that was inside the composite function, and 3 du dx was the 6x that was multiplying the composite function. Now, since all of this is being multiplied together, I can change the order of the terms here, and I can go ahead and write that this equals to the integral of 3 times cosine of u times du dx dx. And what we notice here is that these two dx's can cancel each other out. In other words, we can just cross out the dx on the denominator as well as the dx at the end of the integral. And we're now left with the integral of 3 times cosine of u du. In other words, we've rewritten our integral in terms of the new variable u. Notice how much simpler this integral is compared to the one we started off with. And now, all we have to do is integrate this with respect to u. And doing so, we quickly find that's equal to 3 times sine of u plus some constant of integration, c. Finally, we replace u by x squared plus 1 in order to write the final answer in terms of x. So that would be 3 times sine of x squared plus 1 plus some constant of integration, c. And that's the answer. And so before working through this second example, if I were to summarize the steps here, we started by comparing the function that was multiplying the composite function to the derivative of the function that was inside it. Once we noticed that it was a scalar multiple of the derivative, we knew that we had to use U substitution. And U substitution itself can be summarized in 3 steps. The first step, and I'll just write step 1 here, is to write the integral in terms of the new variable u. So I'll say write integral in terms of u. Done. And once that was done in such a way that we simplified enough so that the only variable was u, we then integrated with respect to u. And so I'll call that step 2, and I'll just write integrate with respect to u. So I'll just write w r t as in with respect to u. And once that was done, we moved on to the third and final step in which we wrote our final answer in terms of x. And all we did there was replace u by x squared plus 1. And so I'll go ahead and say step 3, right answer in terms of x. Done. In other words, as soon as we know that we can use U substitution, we follow the 3 steps here. And in fact, let's do that for the second example. We have to integrate 5x squared times e of x cubed plus 2. Well, again, we notice that we're trying to integrate a product of 2 functions, and we also notice that one of those 2 functions is a composite function. Indeed, we have e of x cubed plus 2. And so we compare the function that's multiplying the composite function, so that would be 5x squared, to the derivative of the function that's inside the composite function, so that would be x cubed plus 2. And so if we call x cubed plus 2 u, in other words, if we define a new variable u as x cubed plus 2, then its derivative du dx is equal to 3x squared. And comparing 5x squared to 3x squared, we quickly see that 5x squared is equal to 5/3 of 3x squared. In other words, that's 5/3 of du dx. And we could write that here as well. That's 5/3 of du dx. And since this function is a scalar multiple or a constant multiple of du dx, we can go ahead and use U substitution. And for that, we follow our 3-step method. The first step, we write the integral in terms of the variable u. In other words, we go ahead and write that this equals to the integral of 5/3 of du dx times e of u, with our dx at the end here. And rearranging this a little, we can see that this is equal to the integral of 5/3 of e of u times du dx times dx. We now see that the dx's cancel each other out, leaving us with an integral that is written only in terms of u. In other words, that's the integral of 5/3 times e of u du. Now that we've rewritten our integral in terms of the new variable u, we move on to step 2, in which we integrate with respect to u. And in doing so, we quickly find that's equal to 5/3 of e of u plus some constant of integration, c. And now that we've integrated, we move on to the third and final step, in which we write our answer in terms of x. And for that, we replace u by x cubed plus 2. And so that would be 5/3 times e of x cubed plus 2 plus some constant of integration, c. And that's the final answer. And that's how to use the method of U substitution for integration. And that's it for this tutorial.